Okay, this is practice problem number 2. Oops. For homework number 1. So on this one, we've got somebody and they're planting trees. My pen's really been acting up. Maybe I'll just use my finger. Let's just do that. Okay, so this will be kind of like a 4-year-old is writing it, but that's okay. So we've got somebody planting trees. Here they are. They're happy as can be because they think they're going to make some money. So let's see if they are going to make money. So we know that this person, it cost them $1,000 to plant these trees today. So this right here is the present value of these trees. Okay, and then we know that in the future, so in 40 years, these same trees can be sold, probably as lumber, for $15,000, right? So this is the price. This is the money we're going to get. And this right here is the cost, right? How much it took in order to get the product. So the question is the cost greater than the price, or is the price greater than the cost? Obviously, we want the price to be greater than the cost. Because if this is greater, then that means we're going to get more money than we spent. Because if it's the other way, and if the cost is greater, then you spent more money than you got, and the whole thing was worthless. So how are we going to find these two things? Because although we know them right now, right? There we go. So we know the cost and we know the price. The problem is they are separated by a period of time, 40 years. So we need to scale them so that they are the cost and price at the same period in time. And that is the only way to make a fair analysis of if this is a good idea or not. So what we're going to do is we're going to determine the present value for the total amount we can sell the trees for. So we're going to use our equation PV equals FV over 1 plus the discount rate raised to n, the number of years, right? So we know the future value. We know that in 40 years, our trees will be worth $15,000. And we know the discount rate. We assume a discount rate of 7%, and we know that this is over a period of 40 years. Now, a lot of you probably have questions about this discount rate. How did we pick this? This isn't just inflation, right? This is something else. And there's a lot of kind of street smarts here on exactly what discount rate you're going to pick. It involves inflation, and then also how much you would have rather invested that money in something else that could yield more money. So this is mixed in with how much do you care about selling trees. The more you care about selling trees, the less likely you are to need to make as much, the less likely you are to care about that amount of money, and more you care about growing the trees. So you could reduce this discount rate right here. Okay, so we do that. We have all those numbers, we plug it in, and we get the present value of those trees as they're sold. So the present value of the price of the trees, which is $1,001.71. So in 40 years, we can sell them for $15,000, which means today, in today's money, that's $1,001.71. And that means that what we're going to sell them for, or the price we're going to get, is greater than the cost, both which have been discounted to the same time. So these are now in the same dollars, $20. And so because the price of the trees is greater than the cost, then it is actually a worthwhile project, although your actual profit is going to be $1.71. So big deal. That's not going to get you very far, but it's something, right? So go ahead and do it. Okay, so that is our practice problem number 2. Sorry, my pen's freaking out, and this looks like a 2-year-old wrote it, but you know what? It's not too bad.